You press the power button on your phone, and a few seconds later, you are at the home screen. But in those few seconds, your phone executes one of the most precise startup sequences in consumer technology. Let's break down what actually happens. The moment you press the power button, electricity flows from the battery to the processor. But the processor doesn't know what to do yet. Its memory is empty, so it looks for instructions in the only place that has them: a small chip called ROM, read-only memory. This chip is physically bound with code during manufacturing and can never be erased. The code in ROM is called the bootloader. Its only job is to find and verify the next piece of software in the chain. Here's where security comes in. The bootloader doesn't just load the next software, it verifies it using cryptographic signatures. Each piece of software is signed with a digital certificate. The bootloader checks, is this signature valid? Has this code been tampered with? If verification fails, the phone refuses to boot. This is why you can't just install any operating system on an iPod. The bootloader will reject it. This chain of verification is called secure boot. Each stage verifies the next, creating a chain of trust from the ROM all the way to your apps. And understanding this sequence reveals why phones work the way they do. And if these technical breakdowns are useful to you, hit subscribe, because we explain the mechanism behind everyday technology. Once verified, the bootloader loads the kernel, the core of the operating system. On iPhones, this is XNU. On Android phones, it's a modified Linux kernel. The kernel takes control of the hardware. It initializes the processor cores, allocates memory, sets up the file systems, and loads device drivers for the screen, touch screen, cellular radio, and cameras. Each driver is a small program that tells the kernel how to communicate with a specific piece of hardware. Without drivers, your operating system can't use your hardware at all. Next, the kernel starts system services. These run in the background constantly. The service that manages notifications, the service that handles phone calls, the service that syncs your data. On Android, these are called daemons. On iOS, they are called launch daemons. There are dozens of them, and they all have to start in the correct order. Some services depend on others. The notification service needs the network service running fast. The app launcher needs the graphics service ready. The boot sequence has to orchestrate all of this. And finally, the system loads the user interface. On iPhones, this is Springboard. On Android, it's the launcher. This is what draws your home screen, handles your touches, and launches your apps. Only when this loads do you see the lock screen. So those few seconds involved ROM code, cryptographic verification, kernel initialization, driver loading, service orchestration, and interface rendering, all before you even unlock your phone.